Hi everyone, today we are going to talk about the directing effects of a directing group attached to a benzene ring. Okay, knowing how to answer this type of questions is important because this is the first step before you can go ahead with the drawing of the electrophilic substitution mechanism. So what I want you to do is I want you to think of this through this analogy that the directing group is like a traffic warden, right? What it does is that it directs a group, the incoming group, all right? So it directs the incoming group. Okay, so this is the first idea. It is the one that directs the incoming group, and the other idea is that when you use it as the reference point, it is at position 1. All right, so this is the reference. All right, so just take note of that. Okay, so if I'm using this methyl group as a reference, this will be position 1. If I'm using this hydroxyl group as a reference, this will be its position 1. All right, so it is relative to the group that we are looking at. Okay, so let's take a look at the three different scenarios of directing groups. All right, we have co-directing, where the two groups are added to the same position. Okay, and so the two groups are direct to the same position, and the new group will be added to the co-directed position. All right, so if we look at the second example, all right, we will be able to see this. So if I take the OH group as reference from your data booklet, you will know that it directs to this position here, this position, or this position. All right, and if you take note of the NO2, it should direct to the third three position, which is here or here. So what this shows us is that both of them will direct to either this position or this position here. Okay, so this is we can form either of these products as the major product. Okay, so this is the first idea. Right, the second idea is the idea of competition, right, where the two groups direct to different positions, and so the more activating group wins. So you can see that in the first example, all right, our OH here, okay, what it's going to do is that it's going to direct to these three positions, right? But for this methyl group here is going to direct to these three positions. So as we know that the OH group, right, is more activating than the CH3 group, the methyl group, all right, so it will be dominant. So what is going to happen is that we'll only be able to direct to the green positions. Okay, and so since this position is occupied, all right, it will not be filled, so we can either fill this position here or this position for as our major product. Okay, so let's move on to our last case where we talk about blockage. All right, so I would like to use the analogy of a seat that is taken up. Right, so the position is occupied and so it does not get substituted. Okay, so we have seen the example previously. This position is blocked. All right, so one more example. Okay, so take a look at these few reactants. You'll realize that the conditions are different. In the last case, we are using bromine gas, Br2 in aqueous condition. All right, so what is going to happen is that you will know that this is a 2,4,6 tri substitution. Okay, so it's going to be add to all three of these positions here. But what we can see is that one of these positions is blocked. All right, so we can only attach it to the fourth and sixth position. So how do you actually count this position here? Since this is our reference point, this is 1. We will move towards the direction where we can encounter another group at the earliest point in time, and this will be our methyl group. So this will be 2, 3, 4, 5, and 6. Alright, so these are the three different points for our directing effect, so just take note of them. So I'm going to repeat this again. We have our co-directing effect where two different groups direct to the same position, so the new group is added to the co-directed position. We have competition, where two different groups direct to different position, and so the more activating group will win. Alright, it's the more dominating one, it will give you the major product. And lastly, uh, blockage prevents the substitution reaction to occur at that position. Alright, so this is a summary of the directing effects for the electrophilic substitution mechanism.